Good evening, all. Today we will start question number E. Question E. So set A is given that same set A equal to set of all human beings. Set A equal to set of all human beings, and relation R is given here. What does the relation means? X comma X such that X is father of Y. X is father of Y. This also the same problem discussed yesterday, that type of model question. So first we will check the reflexivity. So reflexive means what? X comma X should belongs to R for all X in the set A. Clear? So we have to check whether X comma X belongs to the set or not. So see that first it is not possible because X cannot be a father of X. For example, myself, I cannot be father of myself. So I can say that X comma X does not belongs to R. So clearly R is not reflexive. Clearly R is not reflexive. Next, check the symmetry. If I am taking symmetry, what is the symmetry definition? If X comma Y belongs to R, then Y comma X also should be in the relation. So that is X is, what is the relation? X is father of Y. We are reversing means what will happen? Y is son of X. Y is son of X, it should not be a father. So clearly Y comma X does not belongs to R. So R is not symmetric. Clear? R is not symmetric. Suppose next, what is that next? Transitivity. The transitive property is if A comma B belongs to R and B comma C belongs to R, that should give A comma C belongs to R. Suppose I am taking if X comma Y belongs to R and Y comma Z belongs to R. So that is, what is the meaning here? X is father of Y and Y is father of Z. Clear? X is father of Y and Y is father of Z. So which means, what is that? X, Y, Z are the three persons. We are given that X is a father of Y and Y is a father of Z. So Z I am taking son means Y will be father and X we have to take it as grandfather. See that Y is a father of Z, true. X is a father of Y, true. But what is the relation between X and Z? X is grandfather of Z. So X is, we have tried the reason, but X is grandfather of Z. So X comma Z does not belongs to R. Therefore R is not transitive. R is not transitive. Clear? Next question. Question number 2. So what is the set given here? Set A equal to set of all real numbers. Set A equal to set of all real numbers, and relation R is given here. Relation R equal to A comma B such that A less than or equal to B square. This relation we have to prove that the relation is neither reflexive nor symmetric nor transitive, which means it is not symmetric, it is not reflexive, it is not transitive. We have to prove. Clear? So first to check the reflexivity. We are dealing in real numbers. Clear? That keep it in your mind. So real number means we can take the fraction also. So I am taking the fraction here. 1 comma 2 less than or equal to 1 comma 2 whole square. It is my according to my relation, because we know that 1 comma 2 comma 1 comma 2 does not belongs to R, because 1 comma 2 cannot be less than or equal to 1 by 4, because 1 by 1 comma 2 sorry 1 by 2, if you are taking squaring means we will get 1 by 4. This is not possible. So 1 by 2 cannot be less than or equal to 1 by 4. Actually 1 by 2 is greater than 1 by 4. So this is not possible. So we can say that 1 by 2 comma 1 by 2 does not belongs to R. Only one example is enough to prove it is not reflexive. So I can say that R is not reflexive. R is not reflexive. Clear? I have taken 1 by 2 comma 1 by 2 as example to prove that it is not reflexive. Similarly, I need to prove that it is not symmetric. So I need to give an example that this is not symmetric. So what I need to take? First I need to take A comma B belongs to R. Example, very easy example I can take. For example, we can take minus 1 comma 3. We know that minus 1 comma 3 belongs to R, because minus 1 less than or equal to 3 square, that is minus 1 less than or equal to 9, which is true. But what about the reverse? 9 less than or equal to minus 1, is it true? No, it is not true. So we can say that clearly 9 comma minus 1 does not belongs to the relation. So R is not symmetric. Clear? R is not symmetric. R is not a symmetric relation. So reflexivity over, symmetry over. Next I need to prove that transitivity. One thing you have to keep in mind, we want to prove generally means we want to prove S, which means we want to prove it is symmetric, it is reflexive, it is transitive, means we have to prove generally. We want to prove it is not reflexive, not symmetric, not transitive, means it is enough to prove that giving only one example. Okay, wow. So we can take two set of numbers that should be in the relation. So first I am taking what number I can take? This one, 2 comma minus 3 belongs to R, and another number here 2 comma minus 3 belongs to R, and another number starting with minus 3. So minus 3 comma 1 belongs to the real numbers. That is, what is the meaning here? 2 less than or equal to minus 3 whole square. 2 less than or equal to minus 3 whole square, that is 2 less than or equal to plus 9, which is true. And here also, and minus 3 less than or equal to 1 square, minus 3 less than or equal to 1, this is also true. But what about the third case, that is 2 comma 1 but 2 less than or equal to 1 square? It's not possible, because 2 is greater than 1. Clear? So clearly I can say so that 2 comma 1 does not belongs to the relation. 2 comma 1 does not belongs to the relation. So I can say that R is not transitive. R is not transitive. So generally I can say R is not reflexive, R is not symmetric, and R is not transitive. Clear? This only they said to prove. Okay, thank you all. We will see remaining questions in next video. Thank you. Subscribe and share. Thank you.